Welcome everybody to our webinar. Topic today is ALLPLAN visual scripting. Many thanks for your great interest. We are a lot of attendees and it's really a great success for us. Thank you very much. So my name is Anja Neumann and I'm product owner for this project. I'm not alone today. So I have support from my colleague Xingling. And hello, Xingling.
Hello, everyone. Hello, Anja.
Hi. So you will have the biggest part today. You will take over the live part. Thanks very much. Thanks for your engagement. So the agenda today looks short, but it only seems to be. So we have a lot of stuff. And so let's start directly with the introduction of visual scripting. So for which areas can be used visual scripting? So it's ideally suited, let's say, for parametric modeling of complex shapes. So with the 3D modeling tools in ALLPLAN, what we have, you can create almost anything. But on the other hand, the modification is not so easy, let's say. And therefore, visual scripting is a very big effort for you. It's also very useful for, let's say, similar frequently used customized objects. So if you have objects which have to be adapted to given situations only in small points, so also here visual scripting can be very helpful. And a very, very interesting and very important point is that we can also automate work processes with help of visual scripting. And the good thing for you, for everyone, is that visual scripting, so the visual scripting editor, is a solid component of ALLPLAN. So no additional program is necessary at this point. The project start was in July 2018, and already in ALLPLAN 2019, we offered a technical preview. And in 2019, visual scripting is an official component of ALLPLAN for the first time. So it's step one of, let's say, it's an ongoing project. So what is visual scripting? Visual scripting is a graphical program, let's say. So the language behind this is Python. And for a script, nodes will be connected with connection line, and then the script describes an algorithm which will be executed after run. So let's say the core element of a scripting tool are the nodes, and each node, so so-called code block, represents a different action. So for example, you have a node to create a 3D circle, and in the background you have the complete programming code line by line, but this is not necessary, so you can use the node which bundles all of these steps here. And each node has an input and a so-called output port. So this means the data which came in and will be used then from the output port to the next step, let's say. And the data flow is always from the left to the right. So after you started a script, after run a script, so the result could be on the one hand an object in ALLPLAN. It's a Python part which will be created. And on the other hand, you can also execute a workflow with help of the script. And if you want to transfer a script to a partner, so you have, you need two files. The one file is the file for the script with the format pip, and you need also a language file. So this is the workflow, and here you see the files. This is important if you want to share the script with your partners. And if you want to share an object, so the result, let's say, of a script, it's very important to know that the object can't be modified without a script. So if you export the drawing file with such an object, so the partner will see the object, but without the script file, he can't modify it. So it's only to have it in mind. If you want that your partner also can modify this object, you have to send also the script file, so the pip file in this case. So with the delivery, you got numerous examples, and they will be also continuously added, new examples. And these examples are stored in the etc file. And as a reminder, if you want to modify the script of such an example, you have to save it before you modify it. Okay, so as I said, we have numerous examples, and I put 3 to show what is possible with visual scripting. So when you're scripting, it is very important to consider at the beginning which parameters are needed and how you want to influence it in the end. So the way of thinking is important, but Xingling, you will come back to this later, I think. So this script is designed so that reinforcement will automatically adapt to the size of the beam. So the number of rebars can be set either by spacing or by the number or spacing and number. It's only an example to show where you can use it for. And this is reinforcement what you know from ALLPLAN. So it's not created by the script. So we use for this example the reinforcement what we have in ALLPLAN, and you can mark it and you can continue your work as you are used to. So the second example is a script that automates a workflow. So imagine you are planning a building with many rooms, example a hotel or a hospital, and you need to create sections for each room. There are a lot of working steps. So with help of a script, you can streamline this workflow. The section lines will be created in one step. So the depth of the sections can be adapted afterwards. And after concerning the parameters, the sections will be created one after the other. So another example uses a different way of creation the section lines. So in this case, the section lines will be created by a polygon, a polyline. It's a cell, yeah, the workflow is the same, and then the sections will be created step by step. Then a last example about a workflow. So imagine you receive IFC data from your partner, and you have to fill all components with style areas. So on the one side, on the left side, you see here, this is a file what you get. So let's say the empty components, and the material came out of the IFC. And you have also different components like a UD curve volume or a column or walls. And on the right side, you see the result. So because I don't want to do it step by step for each object, so we have created a script for this, which bundles all these working steps. The guideline for the assigning of style areas, in this case, are listed in an Excel sheet. So we have a look in this. So here are the rules. For example, a slab with a material C45 should get the area style 301, and so on. So these are the principles, the rules for the assigning of style areas. So after choosing this and apply, so then you see the style areas will be assigned automatically, which could be very, very helpful if you have a lot of drawing files. So, and you see here the right style areas also in the section. At this point, I'm done with a short introduction. But before we start with the live part, may I introduce a special guest? So, Stephen, Hello, Stephen.
Hello.
Hello, Stephen. So you wanted to make an announcement, or?
Yes, if that's all right with you. It's a fairly short announcement, really. Let me introduce myself first. I'm Stephen Holding. I'm a product manager with ALLPLAN, and I'm very interested in visual scripting for ALLPLAN. I can see many opportunities for using it in the future. And I have an exciting opportunity to share with you all. We already know how creative our customers can be with ALLPLAN. So we want you to show us what you can create using this new visual scripting tool. Now you'll learn a little bit more about how to use it shortly, but we're hoping that once you've had a look at this and seen what's possible, you'll be quite interested to experiment with it. Now, we're not quite ready to share all of the details yet, but we're preparing a community competition, and this is an opportunity for you to show us and everybody else and maybe discover more for yourself what's possible using visual scripting. We have a registration page, which we have a link to show you. So this link is live now. You can go there straight away, or well, preferably after the webinar's finished, and you can register to find out more about the community competition as soon as we've got the details available for you. I will say that the topic is very flexible and it should give everyone a chance to experiment. But although we just didn't quite have everything in place in time for this webinar, we wanted to give you a little heads up and see how much interest there is in the idea of holding this community competition. So please go and register, and we'll send out more information as soon as we've got it ready for you. That's really all I'm here to announce for now. So I'll let Anya pass on to Xinling, and we'll move on to the live demo.
Thank you very much, Stephen. So it sounds great, and yeah, we will see. And the next topic is the live part. So Xinling, maybe you.
Yeah.
So I will change the panel. You are the moderator now, and
yeah, I have to first select the right display. Can you see that?
Yes, we can see your screen. So
yeah, great. Okay, thanks Anya for the comprehensive introduction, and thanks Stephen again for the announcement about competition. And hi everyone, welcome to this live section. And in this live section, I will show you how to create scripts from scratch. Here is an overview of what you can expect from this demo. We'll first do a very quick comparison between normal object and then the object from visual scripting, and see some basic elements and the workflow in visual scripting. And the last but most important is to somehow learn a way of thinking while you're using the visual scripting. So let's dive into it and switch to ALLPLAN. So first, I would like to show this for different objects. It's actually as you may notice, this one is just a normal ALLPLAN object, and the other three is the Python part object, which is created by visual scripting. So if you would like to change the first object, which is a normal object, it's quite, you can do something like change the height of the object. But if we would like to do some more comprehensive thing, like change the total height, but keep the proportion of the distance between each level, or let's say you would like to add another level to it, it's possible, but you have to do maybe from the very beginning. It's not that efficient. But if you have the object which created by visual scripting, it's actually quite easy. You can just double click on that, and you will see a palette which shows all the property or parameter which you can change. Let's say I would like to have it 80 meters instead of 60. So just type 80, and or maybe 20 floors instead of 15, and close the palette to confirm the modification, and the object will be created or will be updated automatically. That is definitely
huge advantage if you can create object with VisualScripting. So so now before we finally start to script, I would generally recommend, if you would like to create a parametric object, you should do some sketch or do some schematic sketch first to understand your object a little bit better. So for this purpose, I have also do a very schematic sketch about this object which we would like to create in this live section. So I have listed some of the most important parameters here, like total height of the tower, major and minor radius, you may not notice that the section or the cross section of each floor is an ellipse, which is normally quite difficult to create in ALLPLAN. And some other things like numbers of floors or overhang distance I have listed, and it will help a lot if you can list some of the parameters which is maybe important for you while create the script. So let's now open the VisualScripting. So so as VisualScripting is now as an official part of ALLPLAN, you can open it directly under tab user-defined objects. Yeah, VisualScripting. So the workspace of VisualScripting is quite simple. Here is mainly the workspace or canvas, we call it. And here's a library with all the nodes which you can use. So let's first try to search the node ellipse, which we'll use as base form for our object. So just type ellipse. And per drag and drop, you can add this node to our canvas. And I would say that our nodes is quite self-explained. Most of the parameters, like center point, minor radius, major radius. I would say for this ellipse, I would like to have a minor radius to 7 meters, for example, and a major radius to 10 meters. 10 meters. And by click the run button here, you will see the previews in ALLPLAN working space, or ALLPLAN model space, actually. And you can also change the shape of the geometry by drag the handles if it is available. Just simple do this like that, and the values that will be automatically updated. And you can even type like a unit in this area, like let's say 700 centimeter, and it will also automatically convert to the local unit which you have set it here. For example, we have here meters. And for the customer from US, we also adopt a US customary unit. Let's say if you want this to be 30 inch and 30 feet and 10 inch, you can just type it like that and it will be automatically converted. If you set the environment unit to foot and inch, it will be keep showed as a foot and inch, not as a meter, just as we just said. But for the demo, for this demo, we'll use a metric unit. So let's change it back to 10 meter. So now we have the base form of the object. So let's take a look at the object again. It's actually consists of two parts. One is this glass facade, and the other is these slabs between the glass facade. So I would say I would start with the easiest part, which is the glass facade here. And there are several ways to create that. The easiest one is to use extrude, which we also have. You can just type there. Extrude. So you can see the notes here, but I would not recommend that because if we see the other two examples, because we want to do all these three examples, if we see the other two examples, the cross section of the glass facade at each level are different. That means if we use extrude, it's quite difficult to change to control the cross section at each level. So a better way is if we can move or copy the base form of this ellipse along z direction and use that as a cross section and create loft from that. Using loft to create a geometry from that, then you will get a better options. So let's first search for the move node. For this purpose, you can use move by point, of course, but for our demonstration, I will use the move by vector. So you may also notice that there's a parameter objects to move, which is in red. And you can also notice that the run button has a gray out, which means you cannot click on that. That is because this parameter must be connected before you can run the script. So let's try to connect our ellipse to it. And now see the run button is available. So let's say if you want to reconnect the port or reconnect this wire, so you can press Control button and then left click on the port to disconnect it. And then let's say this time we will try to connect to distance. But you say that we cannot do that. The reason is that if you see the tooltips from this part, it says that the distance required a data type of vector 3D. But the ellipse itself is actually a data type of arc 3D. So it doesn't match, so you cannot connect them. So let's connect back to ellipse to the object to move and just take a more detailed look at move by vector. So this node move by vector has several parameters. For us, which interested, it might be the distance and the repeat count. That means if we can provide the distance of between each level and how many slabs we would like to create, we can do it just in one node and create all this kind of cross section. So we can take a look at our sketch again. We know that we have defined some parameter like total height and the number of floors. So the distance required vector 3D. So we can search first for a vector 3D here. And the object is always vertically. It's always vertical. So we use this one by z-axis. And then let's rename it to total edge, stand for total height. And let's say it should be maybe 16 meter. And connect we need another input for the number of floors. It's obviously always an integer, so we can try to search for integer. It's an integer input. Let's rename to slab number, and let's say 15 slabs. And now we need to do some mathematical jobs to divide the total height by the number of the slabs. For that, we need this division. You see the branch of different divisions here. So the one we need is actually under the expander math operator. So we can just add this operator division here and connect the vector to this value and the integer value to this port. And we can then connect the result to the distance. Yeah. And the repeat count is simply equal to the number of slabs. So let's connect it. Let's run the script again and check. Let's first save it before we run it. Let's say it should be tower A. Now let's run it and see if it is correct. It seems to be correct. I would say. So now we have the cross section at correct position. So we need a loft to do the rest job for us. So let's add a loft to our canvas. So before connect the ellipse or the cross section to it, let's check the result by left click on the node and all the results from this node will be displayed in green. And we notice that the last or the first one, the base one is not included in the result. It is actually the object or the result from the first ellipse. So that means we need to connect both of them into the loft to create a complete facade. So let's just do that. And save again and run the script. Yeah, it seems to be correct. We can check the result by close the VisualScripting, and it will ask if we would like to save the script and the object simultaneously. Yes, you can just click. But oops, as nothing happened. So the reason for that is there is a small setting there below the nodes. If you notice, this setting there says this node will only show the previews, but not create models. So in order to create a model, we have to toggle the settings. Just click on that to turn off the preview and turn on the option to create a model. And now let's close the script again. And we have a huge column actually. But as a normal glass facade, I would say there is no surface here and at the bottom. So we can change it. So let me first delete it and open the script again. Let's say there's an option here, close volume. Let's just uncheck the box. So, and run the script, close VS again, and create object. So now it's correct. But as we say this is a glass facade, it should have some material on that, or it should be translucent. So we should give it some material, let's say. So let's delete again, create object, open the VisualScripting. So as for the normal object from Outline, we have the option here to change the format. So we can do same thing for the object from which is created by VisualScripting. Just search for the node format and add it to the canvas, connect object to it. As the format will create the object for us, we do not need the loft to create an object for us again, so we can turn it off. So if now we run the script, we can see the objects now in blue. So the reason for that, the color of the color setting in this node format is set to blue by default. And for us, what we are searching for is the setting about the surface. We can just click on that and select whatever material or texture you have prepared and add it to the surface. And now if we close again and save the script, we can check that it's now translucent. So we have just created the first part of this first example. So the second part actually is those slabs. So let's go back and see our sketch again. We see that the base form from all these kind of slabs are actually an offset from the cross section from the glass facade. So that means if we can use some nodes to create offset for us, so we literally create the base form. So let's do it. Let's just delete the old one and open the VisualScripting and search for a node called offset. So we have also several different offsets. As we know that the ellipse itself is a data type of arc3D, so what we need is offset arc3D. So just add it. And the next point is we should define which object to offset. As all these kind of slabs will be created at the level where the cross section of the glass facade located. So it will be very simple if we can find all the cross section and connect it to offset node. So here we already have collected all the cross section for the glass facade. So we can just connect it to the offset. So we have the object, but we still need to define the distance. How far would you like to offset the object? So the distance itself requires a length object, a length data type. So let's search for length input, I would say. Yeah, that's, and let's rename it to offset. And let's say it should be 1 meter. And connect it to it. And move it to here, so it will keep well organized. Save and run the script again. So we see that it's somehow correct. It's create the new base form, but it's somehow not in the right direction. What we would like is actually this ellipse, this base form outside of the cross section, as we defined it as overhang. So we can do it simply by type -1 here. Sorry, -1 here, and it will create the object for us. But I would not recommend that, because it's somehow not that intuitive. Because we defined the parameter as offset as should be a positive number if you want a base from outside of the cross section. So the easiest way, we can use another node called negative, which reverses the sign of a value for us, and reconnect the value to it. And run the script. If we now change the value to a positive one, it will do the correct job for us. So now we have the base form. So the next step is to give thickness to this slabs. This can be achieved simply by using extrude. Let's add it to our canvas and connect the base ellipse to it. And the extrude along vector requires another vector indicate the extrude direction. So we need another vector 3D in Z direction, and let's call it thickness. And let's say it should be 1 meter and connect it to the extrusion vector. I will move it to the left side to keep the script a little bit well organized, and save the script and run the script again. So now we can try to check if it works. Like I would say we have thickness of 3 meter, or maybe even more 5 meter. You see that it's actually not works very well. It's not saying the thickness doesn't work, but the total height is not kept as we change the thickness. So the reason for that, if we check our sketch again, is we use, as we can see here, we use the total height divided by the number of the floors to calculate the distance between two levels. But as actually we should consider that we should subtract the thickness of the highest level from the total height, so that so that if we change the thickness of the slabs, the total height will keep constant. So to do that, we need a new node called subtraction. It's also a new math operator. So let's just find that one under math operator, and let's reconnect this value to it, or reconnect the total height to it. It should minus the thickness of the slabs. So let's connect it and let the result back to the division node. So if we now try to run the script again, it seems to work. That means even I give an extremely large number to this thickness node, that's 10 meter, it will always keep under 60 meter as we already defined. So let's check it back to 1 meter and toggle the setting here to show the object, turn off the preview, and close the VisualScripting to create the object. So, well, somehow we do create the first example, but for the other users, for the one who do not create this object, and for the one who receive the object receive this parametric object from others, and would like to reduce it and change some parameters. So if now you double clicked on that, you will find there, although we have every parameter there, but what a mess there, we cannot find anything, I would say. So actually, so the next step, I will try to clean it up to make it more easy to use, or let's say user-friendly a little bit. So let's open the script again. So you may notice that in every node, there's a small t there. So let's run the script first. There's a small t here. This t means under which expander it should be placed. For example, let's first change this name. We can also change the name of the parameter. So let's first change the total at this value to the number of the z to, let's say, total height. Let's try total height. And you can see it will be updated automatically here, and can now say it is a parameter of a tower. And you see there the expander will be renamed, and the total height is now below the expander parameter tower. I will do it for all the nodes here. I will do it relatively quickly. So the slab number, I will also say parameter tower, and that should be number of slabs. And the ellipse should be parameter ellipse. And for the center point, as we do not need that at this point, so we can turn it off by uncheck the visibility box here. And the major box also do not need that, and this one can all be turned off. And this can just show the handles, we do not need that. And the rest I will keep it is. Offset is a parameter of, let's say, slabs. And this should be called offset. And the thickness again is also a parameter of slabs. As you can see, you can also choose the expand text by click on the drop-down menu. And let's say its name will also be thickness. And the operators for us not important. We can turn off all the parameters just by clicking this setting or this button there, turn off. And the same to the division, and same here. And format, for the format here, as we already choose the style for the service, we also do not need this part, so we can just turn it off. And also here, and I think here's too. Okay. So now if you look at the left side of the palette, left side of the screen, this is the VisualScripting palette. It's now, let's say, well organized and clean it up. So if now we close the script again and save the script and the object, and double click on the object to try to change it, it's now showed more clear, organized, a well-organized parameter structure. Let's see. So let's try to change something here. Let's say it should be 18 meter high, or maybe 17. This doesn't matter. Or 18 floors, and confirm the to change by close the palette. So the object is automatically updated. So that are pretty much for the first example. Let's the height.
So the height changed. What?
Yeah, it's the you can change the height simply by change the parameter here. Just like let's say make the 40 meter.
Yeah. Okay.
Just very simple. Okay, let's close it. So we that's pretty much for the first example. Let's take a look at our second example. You may notice that there are primarily two major differences. So one is that if the second object is twisted, that means it's not a straight tower anymore. It's rotated a little bit at each level. And if you see it more careful or more in detail, you will find that the thickness of each slab is no more constant. That means the thickness at bottom level is much thicker than the one at top level. So I will first move this object a little bit so we can see another example a little bit better. So to achieve that, to achieve the second example, I will try to reuse the script of the first one. So let's start the script again and rename it to, let's say, tower B, and run the script. So now we have the one which is created for the first example. So let's think about what we need for the second example. So it's obvious that we need something can rotate the cross section because the glass facade will be created, or let's say wall created based on the cross section. So if we can rotate the cross section a little bit, we can achieve this effect automatically. So let's try to search for the rotation. Rotate, and add to our canvas. So let's take a look at it. At first, we need objects. So we know that the object should be the cross section. So let's reconnect all the cross section here to the node rotate and connect the result of it again back to the loft. So so we just, let's say, redirect the data flows. So let's take a look at our nodes rotate again. There are also, this time we see here we need something like angle along Z direction. So we can check that it require a data type angle. So let's try to find something about that. Let's say field list angle that will properly do the job for us. And the start angle of that is defined the angle at the bottom level, which are not interested for us, so we can turn it off. And end angle, which defined the angle at top level. So let's say it should be, for example, 118 degree. And the division is equal to the number of the slabs. So we can reconnect the slab, the result from the number of slab to it, and connect the angle list back to the Z angle. And we can also change the name. Let's say it should be parameter tower. And let's save and run a script and try to see if it is correct. To make it clear, I will close the preview of the move object. move nodes, and also the settings here are also necessary, not necessary here. So yeah, it seems to works. So we have also finished the first problem. For the second problem, we need to give a thickness or a variable thickness to each level. So let's check our thickness. A thickness is a vector which require a length or a double. Let's say. So if we can have a node to create a list of lengths, yeah, a list of lengths that will probably do the job for us. So let's find another one, like called field length, which almost do the same thing as the angle or field angle. So the start length, we know that we start from bottom to top. So the start length is the one for the bottom one. So let's say it should be 2 meters. And the start length, let's rename it to thickness bottom. And level is the one for the top one at the top level. So let's say T top. And the division is also equal to the number of slabs. Let's connect to it and reconnect it back to the thickness. Before we run the script, let's take a look at our sketch again. So we just calculated the distribution height, which is total height minus thickness, by using this node. And this node takes the result from this node as an input, but it was one value, but now it's in the list. So what we need is to extract the last value from this list and take that as an input back to this operator node. So the one we need is actually the item, as a list item. So we can insert and connect the list of the thickness to it, or let's say I just reconnect it and set the index to -1, which means it's the last item in the list, and I connect the element back to this node. And now save and try to run the script. Yeah, I would say it works. I can turn it off because it's not necessary here. And this should be under parameter slabs. So if now I change the thickness of the slabs at the top to, let's say, 0.5, you can see it becomes thinner, and I can also change the twist angle. I should change the name of that. Let me do it. It should call twist degree, test degree. So let's change it to, let's say, 225 degrees. Yeah, let's just do the job. Okay, so now I can close the object, close the VisualScripting, create the object again, and we see it. Yeah, it's almost done.
Yeah, it looks great. Looks great.
Yeah.
Yeah.
But somehow, actually, this waving effect is not that attractive. It's not tasty for me.
You don't like it, or?
I don't like it. It's I think it can be more elegant if we can shrink it a little bit. So for that purpose, I prepared the third examples. So let me first move the object a little bit. So I open the script again and save it under a new name. Let's say Tower C. And run a script. So let's take a look at our third example. So the easiest way to do that is we scale the cross-section down a little bit at each level based on the height of the cross-section. That means the cross-section at the top level will keep constant, and also that one at bottom level will keep constant. Only the one in the middle will be scaled down a little bit. And for that, I will create another sketch about it. This is this one. It seems to be a little hardcore here.
So this is a special way of thinking, what you mentioned, or?
Maybe.
So you have
depends
to
how you understand
it.
Yeah.
Okay.
I've prepared this sketch. The idea is that if we can fetch the vertical value from every point on this curve, we actually get the scale factor list correctly. And as you can see, I defined the horizontal axis as the relative height. That means the 0 is the factor, or the 0 at the 0 point is the factor for the scale factor. Is the scale factor for the bottom cross section, and the top one is for at one with one is for the top section, and the one in the middle, which is desired scale factor, is for the one in the middle. So I would say if you have these three numbers, you can create parabola based. You can calculate you can calculate a function from that for this parabolic function. So, but how to create that, or how to calculate that, is way beyond the scope of this webinar. I will not show that. I will just show you this is the result of the calculation if you have these 3 points. And let's back to VisualScripting. So we need, first of all, a scale node to scale down the cross section. So let's search for the scale. There are 2 different scale types. One is scale uniform, and the other one is general scale. So we know that we just want to scale the cross section in Z and Y axis, not in Z direction. So X and Y, So we just need just normal scales. So, and again, we should redirect the object or the cross section to it and reconnect it back to the loft. So we need to define the XY the scale factor for the parameter X factor and the Y factor. For that, we need a customized function to calculate factor for us. So for that purpose, we need a node called function. As we know that we have 2 variables here, so we need the one with 2 variables, X, Y, and insert it into our canvas. So first of all, we need to define a function. I've already right here. So and also prepared. This is written in Python syntax, so you can just copy it and paste it in the property tab here. And so now we have the function, a customized function. So next step is the X. The X, as said, it is a relative position of each level. So it's just simple, let's say double list between 0 and 1. So let's find something called double division. And the start value should be 0 and end value should be 1. That's correct. And the division is also equal to the number of the slabs. So let's connect it back to it. Oops. And connect the list to X. So for the y is actually for the parameter, y is actually the desired parameter we want. So let's need a double input and rename it to scale factor. Scale factor. And here also scale factor. Let's say 0.5. And change the expander name under tower. I say it's much better. And connect it to the parameter y. So, and again, connect the result of that to both parameter x factor and y factor. So let's now save and try to run the script. Yeah, we are almost there. I would say I will clean this kind of things up. And the preview here is not necessary anymore, so I can turn it off. So also the parameters here, I can also turn it off. So I think much better now. So I can close and save the script, create object. So as you can see, we have created the final object or the final example of that. We can try to change some parameter of that and see if it works. So let's say the scale factor in the middle should be, let's take an extreme value, 0.1. You can say it's yeah, quite, how to say that, unrealistic, let's see. You can also change it back to, let's say, 0.7. See much better, and maybe high, a little bit higher, and a little bit more slabs in between, or even the slab thickness, or maybe the offset, let's say 2 meters, and close to confirm the change. Yeah, that is pretty much for today's live section. I hope you can somehow follow it and enjoy it. Now I give my word back to Anja. Yeah, Anja?
Yeah, Singling, thank you very much. So it was a really cool demonstration. So have a nice afternoon. And yeah, hopefully we will see you soon for the next webinar.